This ShowMe is about how to use the discriminant to make decisions about, to draw conclusions about how many answers there will be to a quadratic equation, or how many times the graph of a quadratic function will make contact with the x-axis. The discriminant is the part of this formula that's written in red, b squared minus 4ac. If that number there under the radical happens to be negative, then we will not be able to get any real solutions for our equation, because the real numbers don't supply square roots for negative numbers. If b squared minus 4ac, if the discriminant is 0, then there will be exactly one answer, because adding and subtracting 0 have no effect in either case. If b squared minus 4ac is greater than 0, well, we know that positive real numbers do have two square roots, positive and a negative. So whenever that discriminant is going to be positive, we'll have two answers to our two solutions to our quadratic equation. Let's take a look at that in a little more detail. Consider this quadratic equation, x squared minus 8x minus 9 equals 0. Just focus on the discriminant, b squared minus 4ac. Do always make sure that your equation is in standard form. This one is. In this equation, b is negative 8. So we have negative 8 squared. And then minus 4ac, so minus 4 times 1 times negative 9. Well, the square of negative 8 is 64. Negative 4 times 1 times negative 9 is positive 36. So the discriminant here is 100. What the value is isn't that big of a deal. The fact that the value is positive tells us that our equation will have two solutions. If we plug that into the formula, if x equals now negative b, the opposite of b would be positive 8, plus or minus the square root of the discriminant, which is 10, and all of that over 2 times 8, which is 2. So the two answers specifically would be, 8 plus 10 is 18, divided by 2 is 9. The two solutions would be 9, or then 8 minus 10 is negative 2, divided by 2 is negative 1. The two solutions would be 9 or negative 1. But again, simply the fact that 100 is greater than 0 tells us there will be two real solutions to this equation. So, and that information is useful. Another way to look at this information, another implication of it, would be this. When we solve a quadratic equation, we're finding the x-intercepts, the places where the equation, the graph, the function's graph hits the x-axis. Well, in this case, the graph would hit the x-axis at negative 1 and at 9. So the parabola would look something like this. So whenever the discriminant is greater than 0, the vertex is going to be below the x-axis, and the parabola would open up in this case, giving us two solutions. 9 and negative 1. So there's a graphical interpretation of what we're talking about with the discriminant. Very important to understand this because it'll give you some insights into how to proceed. If you're doing a word problem or a real world problem, it requires you to have real numbers for your answer, and you keep getting negative numbers under your discriminant, there's a problem somewhere. Either there isn't a solution to your problem, or you've got some of the numbers wrong somewhere. Now let's consider x squared minus 8x plus 16 equals 0. Again, let's spend as much time as we can with the discriminant first. B is still negative 8, so that's still going to be 64 for b squared. Minus 4ac this time means minus 4 times 1 times 16. 4 times 1 is 4, times 16 is 64, and 64 minus 64 is 0. So the discriminant is 0. When it comes time to do the calculation, we're going to have x equals negative b, and b is negative 8, so it should be positive 8, plus or minus 0. The square root of 0 is 0, all over 2. There's only one solution, and it's 4. That's just going to happen every time the discriminant is 0. It's going to take the plus or minus aspect of the answer completely out of play. Graphically, this parabola looks a little different from the previous one. It's the same. It's exactly the same geometric shape, but this time the vertex rests where x is 4. So the point 4, 0 is the vertex of this parabola. It still opens up and still has the same shape, but it rests on the x-axis. That's how it has only one solution, and that solution in this case happens to represent the vertex. Again, very important to be able to make these conclusions quickly. It speeds up the process of solving problems and gives you insight into the nature of your solutions. If we just had an audio glitch there, I'm sorry. We running out of power, so I had to plug in the power cord, and I wasn't sure where and when I was paused. I don't think I said any bad words, so it'll be okay. Anyway, we're going to look at this last quadratic equation to finish up this topic. Here again, we're going to focus on the discriminant, b squared minus 4ac. b is still negative 8, so b squared is still 64. This time we have minus 4 times 1 times 20. Well, 64. Now 4 times 1 is 4, times 20 is 80. So we have 64 minus 80, which is negative 16. Now, if you're dealing with a more advanced course in which you've been introduced to imaginary numbers, the discriminant here would be 4i. That's for you advanced students. For you Algebra 1, Pre-Algebra, Geometry students, a discriminant that's negative means that there will be no real solution. When you go to do the calculation, you're going to have x equals positive 8 plus or minus the square root of negative 16 all over 2. But in the real number system, the square root of negative 16 has no meaning. Think about it. If you try to multiply a number by itself, the lowest you could possibly get is 0. If you start multiplying negatives by themselves, you get a positive answer, because multiplying two numbers with the same sign always yields a positive answer. So multiplying two numbers without a sign, 0, gives you 0. Multiplying two positives, or squaring a positive number, gives you a positive result. So the only way that you could possibly get this result is to expand your number system. And in the advanced classes, you more elementary students will. For those of you advanced students, you should already know how to handle this, so probably no big deal for you. But for students in Algebra 1 or Geometry, the conclusion in this situation has to be that there is no real solution. There is a solution. Let me just make sure you understand that there is a solution. We've defined that, but you have not yet encountered it in your courses, most likely, and you probably won't this year. So keep that in mind. There is a solution, but there are no real numbers that will make this happen. I hope that gives you some insight on how to apply the discriminant. Graphically speaking, just to close the loop here, this last parabola, again, is geometrically congruent to the previous two, but its vertex is above the x-axis, and it opens up. So it never touches the x-axis, which is why there's no real solution. We always graph our solutions on the real plane. On the real plane, this parabola never is equal to 0. Now, on the imaginary plane, that's a different game, and that's why you see this stuff over here. Don't fret about that unless that's your game. But if that's your game, this ShowMe wasn't really written for you anyway. I hope that helps give you some insight into how to make quick interpretations and judgments about the quadratic formula and the solutions it provides without actually doing the entire calculation.